Under the hood, Route 53 utilizes a globally distributed network of hundreds of points of presence to resolve queries at the edge of the Internet. The service takes its name directly from Port 53, the traditional, standardized network port reserved for domain name system communications. While Route 53 can act as both a domain registrar and a DNS service, these are entirely decoupled systems in cloud architecture. If you purchase a domain through a third-party registrar like GoDaddy, you can still utilize Route 53 to manage your DNS records. To execute this integration, you first establish a hosted zone within your AWS account. This serves as the logical container holding all the DNS records that define how to route traffic for your domain. When you create a hosted zone, Route 53 automatically generates a set of 4 unique name servers, or NS records, assigned specifically to your configuration. You copy these 4 Route 53 name server addresses, navigate to your third-party registrar's management panel, and update the registrar's NS records to point to Route 53. By completing this specific handshake, Route 53 immediately assumes authoritative control over your domain namespace. Regardless of the volume of DNS queries you receive, AWS charges a flat administrative cost of 50 cents per month for every hosted zone you create. Because this baseline pricing is billed per zone, abandoned test domains in multi-tenant environments will steadily drain a budget. Identifying and cleaning up stale hosted zones is a mandatory cost control measure. Hosted zones fall into 2 categories. Public hosted zones contain records that route traffic on the public internet, making your endpoints visible globally. Private hosted zones contain records that define routing exclusively within an Amazon virtual private cloud, keeping your private infrastructure completely hidden. Whether public or private, mapping host names involves strict rules, particularly at the zone apex, which is the root of your domain. You cannot create a standard CNAME record at the root domain. Attempting this causes a protocol violation. AWS solved this with the alias record, pointing the zone apex directly to an AWS resource. Route 53 then automatically detects underlying IP changes and resolves queries dynamically. Alias records also eliminate query costs. You are never billed for DNS lookups resolved to alias records mapping to AWS infrastructure. Because AWS dynamically manages the mapping, you cannot set an arbitrary time to live on an alias record. To the querying client, this backend complexity is invisible. An alias record is always presented as a standard IP address mapped via an A or AAA record. There is one strict constraint. You cannot create an alias record that targets a raw EC2 instance DNS name. If you are deploying highly available services like application load balancers or CloudFront distributions at the apex of a corporate domain, bypassing the CNAME limitation with an alias record is the only viable architectural path. Routing traffic is only effective if the destination is functioning. Route 53 utilizes integrated health checks to ensure it only returns active, healthy IP addresses to clients. This monitoring system evaluates endpoints using a global network of 15 distributed health checkers. By default, a health checker probes your endpoint every 30 seconds. An endpoint is declared healthy only after passing a threshold of 3 consecutive checks. For HTTP and HTTPS endpoints, a probe succeeds if the server responds with a 2XX or 3XX status code. To prevent false positives, Route 53 checks the response body for specific text. Then, a strict quorum rule applies. If over 18% of global checkers report the endpoint healthy, the path stays active. If it drops below 18%, Route 53 triggers automated failover. To allow these probes to reach your infrastructure, your network firewalls and security groups must be configured to permit inbound traffic directly from the AWS public checker IP ranges. This introduces a significant architectural challenge, especially for highly secure resources that are deeply hidden inside the layers of a private network topology. Because Route 53 health checkers reside on the public internet, they physically cannot penetrate a private subnet to ping an internal database or API. To solve this, you build a monitoring bridge using CloudWatch alarms. You configure an internal CloudWatch alarm to monitor your private resources, and then configure your public Route 53 health check to monitor the status of that CloudWatch alarm. By pointing the public check at a boundary metric, you maintain complete internal isolation while still executing automated DNS failover for secure enterprise databases. Once your records and health quorums are established, Route 53 applies programmable logic engines, known as routing policies, to incoming queries. Simple routing is your baseline configuration. It returns one or multiple static IP addresses for a single resource. If multiple values are returned, the client randomly picks one to connect. Simple routing records do not support advanced intelligence, and crucially, they cannot be associated with health checks when Alias is enabled. Weighted routing shifts traffic based on exact percentages. You assign a relative integer to each record, and Route 53 distributes requests based on that record's weight divided by the total sum. Other policies optimize for geography or speed. Latency routing directs traffic to the region with the fastest response time. Geolocation maps traffic by continent, and failover routing establishes strict active-passive disaster recovery paths. For hypergranular control, IP-based routing maps specific incoming CIDR blocks directly to specific endpoints, allowing you to route corporate or ISP-specific traffic to dedicated infrastructure. Finally, the multi-value answer policy provides dynamic health filtering for multiple IPs. When queried, Route 53 evaluates the health status of all associated records and returns up to 8 strictly healthy IP addresses per request. Unlike simple routing, multi-value automatically drops failing endpoints from the response payload, ensuring clients only receive functioning destinations. Selecting the correct policy transforms a static DNS address book into a highly programmable load balancer operating across the global internet. Route 53 scales well beyond the traditional functions of a localized Port 53 server. A query enters the edge network and strikes an alias record, bypassing standard route constraints to point directly at an AWS architecture. The routing path is validated against the global health quorum, pulling metrics across the network boundary via a CloudWatch bridge. A multi-value policy filters available targets, pushing the query down the optimal path to land on a secure, active database within a private VPC. This entire evaluation process executes in milliseconds, completely abstracted from the end user. Mastering the alias boundary, mapping the math of the health quorum, and applying precision routing policies is the engineering standard required to build a resilient, enterprise-grade cloud architecture.